Okay, so everyone get ready because we're going deep on this new asteroid 2024 YR4.
Oh, yeah.
You sent over this excerpt from the Spanish Wikipedia page.
Yeah.
And this thing is making headlines because there's a chance it could hit us in 2032.
Right.
But before everyone panics, let's break down what we know about it.
Yeah.
Its size, its orbit, and what scientists are actually doing about it.
It's pretty crazy how fast everything's happened.
Yeah.
It was just discovered on December 27th, 2024
Oh, wow.
by the ATLA system in Chile.
Okay.
And only a few months later, it's like a main focus for the whole planetary defense community.
It's like a cosmic plot twist. Like
Yeah.
1 minute everything's normal, and the
Uh-huh.
next we've got this potential asteroid threat just hanging over our heads.
Goalie.
So speaking of ATLAs, can you tell us a little bit more about that system?
Sure.
Like what it is and how it works?
Yeah, so ATLA stands for Asteroid Terrestrial Impact Last Alert System.
Okay.
And it's a network of these robotic telescopes that scan the sky, looking for potentially hazardous asteroids.
So like our early warning system for any incoming space rocks? Like a
Yeah.
cosmic neighborhood watch?
Uh-huh.
And it sounds like they found one.
They did.
As of February 14th, 2025,
Mm-hmm.
2024 YR4 has a 1 in 48 chance of hitting Earth on December 22nd, 2032,
Oh, wow.
which is a little over 7 years from now.
Yeah.
And it has a Torino scale rating of 3,
Right.
which the article mentions is the second highest an asteroid has ever gotten.
Mm-hmm.
So what does that mean exactly?
So the Torino scale, it's basically a way scientists communicate how dangerous an asteroid impact could be to the public.
Okay.
And 3 means there's a greater than 1% chance of impact,
Oh, okay.
which means we need to pay attention
Right.
and not panic.
Right.
You might remember asteroid Apophis back in 2004,
Oh, yeah.
which also got to level 3 on the Torino scale and caused a lot of concern.
Mm-hmm.
Like 2024 YR4, it was thought to have a good chance of hitting us.
Okay.
But further observations and calculations ruled that out.
So what's the main difference here?
I think the main difference is the time.
Okay.
We have less time to observe 2024 YR4 before the potential impact date.
So it's a race against time.
Yeah.
So how does 2024 YR4 compare in size to Apophis?
Right. So the size of 2024 YR4 is still a little uncertain,
Okay.
but it's estimated to be between 40 and 100 meters in diameter,
Wow.
which puts it in a similar size range to the asteroid that caused the Tunguska event in 1908
Oh, wow.
that flattened over 80 million trees in Siberia.
Yeah.
Apophis is much larger, though, over 300 meters in diameter.
So even though 2024 YR4 is on the smaller side, it could still pack a punch.
For sure.
What about its composition?
Right.
What's this space rock made of?
So based on spectral analysis, which is a way to look at the light reflected from the asteroid,
Okay.
scientists think it's likely rocky,
Okay.
composed mostly of silicate minerals,
Okay.
probably either an S-type or an L-type asteroid.
Hold on. Can we back up for a second?
Sure.
This spectral analysis thing.
Yeah.
I'm curious, how do scientists figure out what an asteroid is made of just by looking at the light that bounces off of it?
So different minerals absorb and reflect light at specific wavelengths,
Okay.
creating a unique fingerprint that scientists can analyze.
Oh.
They compare these fingerprints to minerals we know,
Okay.
and they can figure out what the asteroid is made of from millions of miles away.
Wow, that's amazing.
Yeah.
It's like a cosmic detective kit.
Uh-huh. Yeah.
So we know it's rocky,
Uh-huh.
but is there anything else that makes its composition unique or interesting?
One interesting detail is its rotation.
Okay.
2024 YR4 spins incredibly fast.
Really?
It completes a rotation about every 19 and a half minutes,
Wow, that's fast.
which is super unusual for an asteroid of its size. And it could tell us about its formation and history.
Wow, that's faster than some washing machines.
Yeah.
Imagine trying to stand on its surface. You'd be flung off in a heartbeat.
Uh-huh. Right.
So let's talk about its orbit.
Okay.
Where does it travel in our solar system?
So 2024 YR4 is what's called an Apollo asteroid,
Okay.
which means its orbit crosses Earth's. It goes around the sun in an elliptical path,
Okay.
the period of 4.05 years.
Mm-hmm.
And its orbital plane is a little tilted compared to Earth's at about 3.45 degrees.
So it's like a cosmic daredevil cutting across our path.
Uh-huh. Yeah. Yeah.
And it already buzzed by us on December 25th, 2024,
Right.
coming closer to Earth than the moon.
It did.
That was just 2 days before it was discovered.
Yeah, that was a close one.
Talk about a close call.
I know. It really shows that even with our technology, we're still vulnerable to surprises from space.
Yeah.
And the next time it'll come close
Yeah.
is predicted to be December 17th, 2028.
Oh, wow.
And this counter is going to be crucial for scientists to fine-tune their calculations
Okay.
and get a much better idea of the 2032 impact risk.
So they'll be watching it very closely.
Oh, yeah, for sure.
But the article says that seeing 2024 YR4 will be difficult from April 2025 to June 2028
Uh-huh.
because it'll be too far from Earth for ground-based telescopes. So if our Earthbound telescopes can't track it, then could space telescopes like James Webb be used to keep an eye on it?
That's a good question, and I'm sure a lot of scientists are thinking about that.
Mm-hmm.
Space telescopes like James Webb could be used,
Yeah.
but it's not that easy.
Okay.
These telescopes have limited observation time,
Right.
and that time is often booked years in advance for all sorts of science projects.
So it's like trying to get a table at a super exclusive restaurant.
Uh-huh,
So you
exactly.
got to plan way ahead of time.
Yeah.
So whether James Webb is used to watch 2024 YR4 depends on a lot of things,
Right.
including how risky it seems if the telescope is available
Right.
and how important it is to look at this asteroid compared to other research.
Exactly.
So it sounds like a lot of tough decisions
Yeah.
about how to use our resources to watch this potential threat.
Yeah, it is.
So let's talk about the big question.
Okay.
What would happen if 2024 YR4 actually hit Earth?
So based on its size and what it's made of,
Hmm.
if 2024 YR4 hit Earth,
Mm-hmm.
it's estimated to release energy equal to about 7.7 megatons of TNT.
Wow, that sounds huge.
Yeah.
How does that compare to a nuclear bomb?
It's about the same as the biggest nuclear weapons ever used.
Wow.
But it's important to remember that the effects of an asteroid impact are very different from a nuclear explosion.
Okay, how so?
An asteroid impact would create this huge shockwave,
Okay.
really intense heat,
Yeah,
and could cause earthquakes and tsunamis depending on where it hit.
that's a scary thought.
It is?
It's like something straight out of a disaster movie.
Yeah,
But the impact location would matter a lot, right?
absolutely. The good thing is our planet is huge.
Okay.
So while the impact zone is still being figured out, it's estimated to stretch from the Pacific Ocean across Africa to India.
Okay.
The chances of it hitting a heavily populated area are pretty low.
That's a little reassuring.
Yeah,
But knowing there's even a tiny chance of it hitting in the next 10 years is pretty unsettling.
it is.
So what are scientists doing to refine those predictions, to get a better idea of where this asteroid might end up?
They're working on a few things.
Okay.
One is looking for old images.
Okay.
They're going through archives of telescope data,
Mm-hmm.
trying to find any images of 2024 YR4 before it was officially discovered.
So like finding a needle in a haystack,
Yeah.
a cosmic haystack.
Right. But if they find any,
Yeah.
it would let them trace its path back in time
Okay.
and understand its orbit better,
Mm-hmm.
which would help them predict where it's going in the future.
So it's like solving a puzzle,
Yeah.
using every piece of information to see the big picture.
Exactly. And the next time it comes close in 2028 will be another chance for scientists to gather more data
Okay.
and improve their calculations.
Mm-hmm.
The more information they have, the better their predictions will be.
So it's not like we're just sitting ducks.
Yeah.
We're using science and technology to understand the threat and maybe even prevent it.
Exactly.
And that leads us to another important part of this,
Yeah.
developing ways to protect our planet. But before we get into that,
Yeah.
let's take a minute to process everything we've learned so far.
That sounds like a good idea. This is a lot to take in.
It is.
Yeah.
Yeah.
And it really is. Discovering a potentially hazardous asteroid is like a wake-up call.
Yeah.
It reminds us we're not alone out there, and there are things that could threaten Earth.
It's like a constant reminder that we're part of this bigger cosmic story,
Right.
and we need to be ready for whatever comes our way.
Exactly. It shows how important it is to keep investing in space exploration and planetary defense.
Mm-hmm.
We have to keep getting better at finding these objects early on
Right.
and have plans in place if we ever need to deflect one.
That makes you wonder what those plans might be like. Like,
Yeah.
what can we do if 2024 YR4 really is going to hit Earth?
Well, that's where things get really interesting.
Okay.
There are a few different approaches to planetary defense.
Okay.
And the best one would depend on a lot of factors,
Mm-hmm.
like the size and composition and trajectory of the asteroid
Okay.
and how much time we have to act.
So there's not just one solution.
No, not at all. Each asteroid is different,
Okay.
and we need to tailor our response.
So let's get into some of those options.
Sure.
What are the main things in the planetary defense playbook?
One that's gotten a lot of attention lately is the kinetic impactor.
Okay.
which NASA's DART mission tested out last year.
Yeah, the one where they crashed a spacecraft into an asteroid on purpose.
Exactly.
That was amazing to watch.
It was.
Can you remind us how that worked?
Of course.
And how it might apply to a situation like with 2024 YR4?
So the DART mission targeted this small asteroid called Dimorphos, which was orbiting a bigger asteroid called Didymos.
Okay.
They hit Dimorphos with a spacecraft,
Yeah.
and they actually changed its orbit a little bit,
Yeah.
showing that this could be a way to deflect asteroids that might threaten Earth.
It's like a cosmic game of billiards,
Ha.
using a well-aimed shot to knock the asteroid off course.
That's a good analogy.
But just like in billiards, the key is to get the angle and the force just right.
Right, if we hit it too hard,
Yeah.
we could break it into smaller pieces,
Which
which could make things worse by creating multiple impactors.
that's a good point.
The goal with a kinetic impactor is to nudge the asteroid just enough
Okay.
so that it misses Earth.
Okay, so the kinetic impactor is one option.
Uh-huh.
What are some other strategies that scientists are considering?
Another is the gravity tractor,
Oh,
which sounds like science fiction.
I like the sound of that.
Haha. So the idea is to use a spacecraft's own gravity
Okay.
to gently pull an asteroid off course.
Okay.
You'd put the spacecraft near the asteroid,
Mm-hmm.
and the gravity between them would slowly change the asteroid's path over time.
So it's more of a slow and steady approach?
Right. The advantage is that it's very controlled and precise,
Okay.
and it's less likely to break the asteroid into pieces,
Right.
but it takes a long time,
Hmm.
which might not be possible if we find the threat too late.
So it sounds like we need a variety of options ready, depending on what the asteroid is like and how much time we have.
Exactly.
What other tools are in the planetary defense toolkit?
Well, if it was a really catastrophic situation,
Okay.
like a huge asteroid we find too late for other methods,
Yeah.
there's always the nuclear option.
That's the Hollywood movie solution.
Right.
But I bet there are lots of issues to think about with that.
Absolutely. Using a nuke to deflect an asteroid is really controversial.
Okay.
It could potentially destroy a smaller asteroid or change the path of a bigger one,
Mm-hmm.
but it could also break it up,
Right.
creating a debris field that could still be dangerous.
So you're trying to stop one disaster, but you might cause another.
Exactly. And there are ethical and political things to consider, too.
Okay.
Using nukes in space is controlled by international treaties,
Right.
and any decision to use them for planetary defense would have to consider the consequences very carefully.
Sounds like a decision that needs global cooperation.
Absolutely. Planetary defense isn't something any one country can handle alone. It needs international teamwork, data sharing, and a coordinated response.
It's a reminder that we're all in this together,
Yeah,
facing these cosmic challenges as one planet.
exactly. And it's
Mm.
not just about figuring out how to deflect them.
Mm-hmm.
It's also about getting better at finding and tracking these objects early.
So it's a two-part approach.
Yeah.
We need to see them coming
Right.
and have the tools and plans to deal with them if they head our way.
Exactly. And that's why missions like NEOWISE are so important. It's a
Yeah.
space telescope specifically for finding and studying near-Earth objects.
Mm-hmm.
The more we know about these objects, their orbits, and their composition,
Yeah.
the better prepared we'll be to defend our planet.
It's like the more we understand about our cosmic neighborhood,
Yeah,
the better we can protect our home.
exactly. And it's not just about protecting ourselves from impacts.
Yeah.
It's also about learning more about the history of our solar system.
Because these asteroids are like time capsules,
Nice.
holding clues about the early solar system.
Exactly. They're leftover pieces from when the planets were forming.
Oh, wow.
And they can tell us a lot about what it was like billions of years ago.
So studying them isn't just about avoiding disaster.
Right.
It's about understanding our cosmic origins,
Yeah.
like a bonus.
Haha. It is. And 2024 YR4 with its fast spin
Yeah.
and its rocky composition
Mm.
could give us valuable insights into the processes that shaped our solar system.
It's amazing to think that something that could be a threat
Yeah.
could also hold clues to our cosmic past.
It's a reminder that the universe is full of surprises,
Yeah.
both good and bad.
Well said. So you mentioned 2024 YR4's fast rotation. What's so unusual about that?
Well, most asteroids rotate much slower,
Okay.
like over hours or even days.
Oh, wow.
This is probably because of collisions they've had over billions of years,
Okay.
which tend to slow down their spin.
Hmm.
So the fact that 2024 YR4 is spinning so fast suggests
Yeah.
it might have avoided some of those collisions.
Okay.
Or it's a piece of a larger object that broke apart not too long ago.
So it's like a cosmic figure skater spinning faster and faster
Huh?
because nothing's bumped into it to slow it down.
Exactly what other clues might its rotation hold about its origins?
Yeah. What else?
Its fast spin could also be from something called the YR4 effect.
Okay.
It's where sunlight can actually change how fast an asteroid rotates over time.
Wow, really?
It's pretty mind-blowing.
Yeah.
But basically, the sunlight that the asteroid absorbs and then re-emits
Mm-hmm.
can create a tiny force that gradually speeds up or slows down its rotation.
So even sunlight can shape these objects.
Yeah, it's pretty amazing.
It sounds like there's still a lot we don't know about 2024 YR4,
There is?
and that scientists are piecing together its story.
Exactly. And the more we learn,
Hmm.
the better we can understand the risk it poses
Okay.
and figure out ways to deal with that risk.
So it's like a cosmic detective story,
Yeah.
with scientists using all the evidence to solve the mystery of 2024 YR4.
Yeah.
What stands out to you about all of this?
I think it's the realization that we live in a universe that's always changing.
Hmm.
We often think of space as being vast and empty,
Right.
but it's actually full of stuff that's constantly moving and interacting.
Right.
And sometimes those interactions can affect us here on Earth.
It reminds us that we're not just watching the cosmos,
Yeah,
but we're part of it.
right.
And we need to be aware of the risks and the opportunities that come with that.
Exactly. And it highlights how important it is to keep investing in space exploration and scientific research.
Mhm.
The more we understand about our cosmic surroundings, the better we'll be able to face whatever challenges come our way.
It's like the more we learn, the more we realize how much we still don't know.
Oh, that's the beauty of science. It's
Yeah.
a never-ending journey of discovery.
And speaking of discoveries, I'd love to hear more about the scientific value of studying asteroids like 2024 YR4.
Okay.
What can they teach us about how our solar system formed and evolved? It's like we're looking back in time billions of years to when our solar system was just forming.
Yeah, exactly.
Yeah.
Asteroids are like leftovers from that time.
Okay.
They hold a record of what it was like when the planets were forming.
Wow.
And by studying what they're made of, how they're structured, and their orbits, we can learn about the processes that created our solar system.
So what can these asteroids tell us?
Okay.
What secrets do they have about our cosmic origins?
One of the most fascinating things is what they're made of.
Okay.
Different types of asteroids formed in different parts of the early solar system,
Okay.
depending on the temperature and what elements were around,
Mm-hmm.
like carbonaceous chondrite asteroids,
Yeah.
the kind that landed in the UK recently.
Right.
They're full of organic molecules and water,
Okay.
which means they probably formed in the outer, colder parts of the solar system,
Oh, wow.
where those materials were more common.
So they brought us a little piece of the outer solar system.
Uh-huh. Yeah, and by analyzing the ratios of different isotopes,
Yeah.
which are like atomic fingerprints, scientists can trace where these materials came from
Okay.
and put together a timeline of how the solar system evolved.
It's like a cosmic history book written in the asteroids themselves.
Yeah.
It is.
What about 2024, YR4?
Yeah.
What might its composition tell us
Right.
about its past and the solar system's history? We know it's probably a rocky asteroid,
Yeah.
either an S-type or L-type.
Mm-hmm.
Based on that spectral analysis we talked about,
Right.
S-types are mostly made of silicate minerals,
Okay.
while L-types have a mix of silicates and metals.
Okay.
Figuring out exactly what it's made of will help us pinpoint where it formed and what processes shaped it over billions of years.
It's incredible that something as simple as a space rock
I know, right?
can have so much information about our history.
Yeah, it is, and it's fast rotation.
Yeah. Could that tell us something about its origins?
Definitely it suggests that 2024 YR4 might have had a different experience with collisions than other slower asteroids.
Okay.
It could be a piece of a larger object that broke up not too long ago.
Mm-hmm.
Or it formed in a place where collisions were less common.
So it's like it has its own story to tell,
Right.
a journey through space and time.
Exactly. And that's what makes studying asteroids so fascinating.
Yeah.
Each one is a piece of a cosmic puzzle.
Mm.
And by putting their stories together, we can understand our own place in the universe better.
It's both humbling and inspiring to think about how much we still have to learn.
It really is.
It feels like we've only just started to understand how complex and diverse our solar system is.
I agree. And that's why missions like OSIRIS-REx and Hayabusa 2 are so important.
Yeah.
OSIRIS-REx brought back a sample from asteroid Bennu,
Wow.
and Hayabusa 2 brought back samples from Ryugu.
That's amazing.
These missions let scientists study asteroid material up close in labs,
Okay.
giving us incredible insights into their composition, structure, and history.
Like bringing a piece of the cosmos right into our labs.
Exactly. And these samples might tell us not only about how planets formed,
Yeah.
but also about the origins of life itself.
Wow.
Some asteroids, like those carbonaceous chondrites we talked about, they have organic molecules, which are the essential building blocks for life as we know it.
That's incredible.
So these asteroids might hold the key to understanding how life began,
Right.
not just on Earth,
Yeah.
but maybe somewhere else in the universe.
That's mind-blowing.
It is. There's a possibility that scientists are really looking into. The study of asteroids is a rapidly growing field,
Yeah.
full of potential discoveries that could change how we see our place in the cosmos.
So what are some of the big unanswered questions about asteroids
Okay.
that scientists are still working on?
One of the main ones is, how did all these different types of asteroids come to be?
Okay.
What made the rocky asteroids, the metallic asteroids, and those full of organic molecules?
Right.
Another question is, how did asteroids affect the early Earth? We know impacts were important in shaping our planet,
Yeah.
but how did those impacts help create the oceans, the atmosphere, and maybe even life itself?
It seems like there's so much more to discover.
There's so much we don't know yet.
Yeah. If you could design a mission to study an asteroid, what would you want to learn?
Oh, that's a great question.
Yeah.
And what kind of tools or experiments would you use? If I could design a mission,
Yeah.
I'd want to go to an asteroid that's never been visited before.
Okay.
One that's really interesting in terms of what it's made, of how it's structured or its orbit. I'd send a spacecraft with lots of instruments,
Okay.
like a high-resolution camera,
Okay.
a spectrometer to figure out its composition, a radar to map its insides,
Wow.
and a lander to collect samples and bring them back to Earth.
That sounds like an amazing mission.
It would be
Like the
incredible.
ultimate field trip, going out to explore these ancient objects and unlock their secrets.
Exactly. And what we learn could help us understand the universe better and even protect our planet from future impacts.
Well, that brings us to the end of our deep dive into asteroid 2024 YR4. We've explored the potential danger it poses,
Right.
the ways we might defend our planet, and the incredible scientific value of studying these objects.
It's a fascinating conversation.
It really has.
Yeah.
And it's a journey that's just getting started.
Right.
Scientists are continuing to track 2024 YR4 and learn more about it.
They are.
And we'll definitely keep you all updated on what they find.
Sounds good.
In the meantime, remember to look up at the night sky
Yeah.
and appreciate the beauty and wonder of our universe.
It's amazing.
It is. Until next time.
Bye.